Wow. Okay. Hello, everyone. Hello. So we good here? Is this on? Seem to be all going okay. Streaming is excellent. Um, I'm seeing interesting. Average stream is too high. Okay, interesting. Um, Preferences. Output. Oof. Oof. See if this works. Is this working? Hello? This going good? I think the bit rate was way too high for a moment. YouTube is not working. Okay. How do I look? Is the stream going okay? Because I recently just okay, excellent. So we are on. Apologies for the bit rate issue. Looks like YouTube is on. Looks like we're completely on. But you got voice volume is good. Because recently I just blew away my entire Mac and I just started. Okay, excellent. So, welcome everyone. Yes, thanks. We are back after a week absence. Uh, Today is going to be the second to last live session we're doing on Thursday by way of Twitch and on YouTube Live. And we've gone through a lot already throughout this whole course. We've done networks, attacking networks, cryptography, vulnerabilities, web security, uh, static analysis, dynamic analysis, and malware. So you may be wondering, like, what are we going to do for the next 2 weeks? Today we're going to focus on a topic that I've been long accustomed to, which is going to be forensics. Computer forensics, yes. It's going to be all hands on today. And this is a topic I've worked with for over 10 years and even have given a presentation to law enforcement on this, um, on how to do investigations. Yep. And I'm going to go back to the good old days and also resort to some of my old talks on giving you the hands-on skills on how to do forensics. So, what is uh, what is forensics? So, if you think about it from, uh, I guess what they call the CSI Miami days, whatever it is yeah, there's an incident that happened. I'm going to show you these slides because it just is really cut to the point. Um, there is an incident, probably criminal. Like, what's the evidence? What happened? Who, what, when, where, how? Like the W's. Okay? So the definition of forensics, from what I have gathered over the years, it boils down to 5 items: the preservation of computer media, the identification of computer media or the evidence, the extraction of computer media or evidence, the interpretation of all the findings, and documentation, which can be used in the court of law. So that's the definition of forensics. But what I really want to show today are three things, really. I want to show three things that will be will be eye-opening to a lot of people. Um, Number one is how to make a bit-by-bit copy of a disk. Number two is how to use a um, forensics suite to manage your case, to see what's going on, to even see deleted files. And then the third thing is how to extract uh, or recover deleted files. Yeah. So one of the things on my first lab that I usually give in the security course is a lab on basic Linux commands and skills. And I always put a question on there is how do you secure remove a file? So if you put RM, straight RM, and that was only your answer, that is a wrong answer. What I want to show today, using forensics tools, is how to recover or Grim Reaper deleted files off of a disk. Oh yes, how to actually how to actually recover a deleted file that was just straight trashed or straight RM'd. Yeah, how to recover those deleted files. Okay, so what I'm going to do right now, I'm on a Mac. Okay, so I'm on a Mac, and the first thing I want to do is let's create a small, simple image to work with. Let's create a small image, and we're talking maybe like 20 megs. Because these days, computer media that you see are in the gigabytes, no longer in the hundreds of megabytes, but we're talking about gigabytes. Okay, so to make a bit-by-bit copy of, a gigabyte plus disk could take a very long time. So what I want to do, and the nice thing about using a Mac, I want to create a FAT32 disk using disk utility. Okay, so what we're going to do first is I want to create a very small and manageable FAT32, which is a universal format disk that can be used and analyzed for forensics purposes. So how do you create such a small disk? So you do the File, New. I want to create a blank new image. And I'm going to save this onto this blank disk, this brand new disk onto my desktop. I'm going to call this evidence. We'll call this evidence. Not 100 megs. Let's do something small. 50 megs. Let's do 50 megs. So 50 megs is pretty nice and small and manageable. The format of this disk, we're going to use ms.fat16, not FAT32, FAT. No encryption, single partition, read and write format. And so we're going to have a very small, by today's standards, 50 megabyte disk. And it's going to be mounted on my desktop. Okay, I'm going to hit done. Okay, so here we are. We have a 50. I'm going to do a file info. This is a 50 megabyte FAT16 disk. Universal MS-DOS FAT16 disk. So that means you can't store a file that's over like 2 gigs. Okay, so here's a disk. Pretty cool. Nothing in there right now. And using this fake disk, I can open up the DMG file and open up my disk away. So why did I want to do this? The next thing I want to do is here we are, we have a disk that we can put 50 megs of worth of content in there. Okay, let's store some stuff in there. And for today's example, let's have some nice fictitious, let's just put some pictures in there. And let's go to Reddit. One of my favorite is the Bikini Bottom. Bikini Bottom Twitter, which is all SpongeBob memes and art. Hello? Are any other pictures showing up? Oh, that's a picture. Okay. Any other pictures? Hello? Let's get some pictures in here. Okay, I'm going to do a file, image, save image as, and instead of it in my documents folder, I actually want to store it on that evidence disk. Yeah. You cannot save this document with the extension. Oh. Need both, okay. Save image as. Here we go. That's a PNG. That's a WebP. Let's have some fun. Let's do a file, save image as. Let's do another save. And we're going to save a whole bunch of these pictures onto my, not this again. Here's a good one. Why is everything going WebP? Okay, we have a WebP. What's this one? That's a PNG. That's a JPEG. Ooh, here's some good one. Here's another one. Let's save an image as. Save it to the disk. Okay. Save image as. Huh. Why is it doing that for me? That's weird. We just use, ooh, let's do this one. Is this a, let's say save image as. And that's a JPEG. I'm going to save this in my, okay, yeah, I'm not sure why it kept on asking me to save the stuff as WebP. Let's see. Save image as. Okay, here we go. Save image as. We're going to do a couple more. Alright, I think we've seen enough. Alright, and I also now, let's say I want to have a text file. So of course I always say, oh yes, smashing the stack for fun and profit txt file. Okay, sure. So I'm going to save this file as, I'm going to save this as stack in the evidence. Okay. I'll just do also frac. Frac. The frac magazine. Yeah, let's save the image as well. Save that in here. Yeah, but they actually have any more new issues? Oh yeah, they still got old issues. Go to issue 68. I'm just going to pick something. Ooh, the art of exploitation. And I'm just going to, wow, okay. I'm going to copy all of this. I'm going to save this all, called frac.txt, in my evidence drive. There we go. Excellent, excellent, excellent. All right, I think we've collected enough stuff. I think we have collected enough stuff to work with. So what we got here in this drive, we have a bunch of MPEG, we have a bunch of pictures, we have 2 text files. Okay, that is saved. 11 items on here. We have 11 items on here. Now what I want to do next is this. I want to delete. So let's take a look at what we got. Okay. Take a look. So this is a JPEG. That's a JPEG. That's a JPEG. That should be a JPEG if I'm not mistaken. Okay, good. What I'm going to do now is I am going to delete all of these. Move the trash. Move this one to trash. And I'm going to go and File, Finder, Empty Folder. Boom. Hey. So now I'm going to eject this disk. I'm going to open it back up. And there should be only 1, 2 files there. Yep, only 2 files, and we had a whole bunch of files that are deleted. Okay. Again, this disk is 50-something odd megabytes. Yep, 50 megs. So the big question is now, let's imagine that this disk, someone committed a crime, and someone deleted a whole bunch of files from this disk, and we want to see what got deleted or what other incriminating evidence is on this disk. I'm going to open it again. Again, there's only 2 files here. There's only 2 files saved on this disk. Only 2 files saved on this disk. The other stuff got deleted. Can we resurrect the other 9 files that got deleted and trashed? Can we do that? Okay. Now, what I want to do is this. We have a complete copy of the disk. We're lucky. We have a complete copy of the 50 megabyte disk. I want to now upload this disk to Kali Linux. Okay. I'll go to my desktop. I'm on my Mac. I'm going to scp evidence.dmg. I'm going to send this up to my Kali Linux. I'm going to scp transfer it over. Got it. Exit. So my Kali Linux will now have a copy of this evidence.dmg disk image. We want to use a forensics tool to analyze this disk for any incriminating evidence. Okay? So I'm going to open up Kali Linux. This time I really need a complete graphical interface. Cool. And why Kali? Because if you actually use Kali, they have all the forensics tools that you need on there. They have forensics tools to help you analyze content. There you go. Cool. Well, first of all, we want to make sure, we want to open up a terminal in Kali and make sure that our evidence got uploaded, and there it is. The evidence.dmg, the disk image file, got uploaded. Yep, from a few minutes ago. 50 megs, evidence.dmg. Again, I'm keeping my disk image small. I'm keeping my disk images small because, analyzing like a gig, couple gigs, it's a lot of disk space and time to make copy of as well. So if you go to Kali Linux, you have probably, like, if you go to the navigation, you see information gathering tools, information gathering tools, Nmap you've used, vulnerability gathering tools, web application analysis tools like Burp Suite, SQL Map, Skipfish, WP Scan, Zap. There's even database assessment tools in Kali, password cracking attacks, password cracking tools, wireless attack tools, reverse engineering. But what about this one? We haven't talked so much about forensics. We haven't talked about forensics tools. And Kali has a number of forensics tools. There's digital forensics tools. There's file carving tools, which I will talk more about today, later on. Forensics imaging tools to make like a copy of a disk, which I'll talk about last today. PDF forensics tools, Sleuth Kit suite, and that is what I am going to use. I want to introduce to you now to what we're going to use. The suite that we're going to use is called Sleuth Kit and Autopsy. Okay? I want to introduce you to Sleuth Kit and Autopsy. So Sleuth Kit is sleuthkit.org, open source digital forensics. It's the Sleuth Kit. There are two pieces to it. One is called Autopsy. Autopsy is a graphical user-based program that allow you to analyze hard drives and smartphones. It had a plug-in architecture to add-ons that you can do in Python. And there's also Sleuth Kit, which is a collection of command line tools and a C library that allows you to analyze disk images and recover files from them. So what I want to do now is open up. The first thing that we're going to use is called Autopsy. So man, Autopsy in Kali Linux. Autopsy starts a forensics browser server at port 9999 and accept connection from localhost. If -P port is given, the server yada yada yada. Okay, so this is a forensics browser, and it uses a lot of Sleuth Kit tools under the hood. I'm going to clear the screen, and I want to do sudo autopsy. And watch what happens. Autopsy is now running. Now keep this running, don't Control C out of it. The Autopsy forensics browser, sleuthkit.org, yada yada yada. This is an older version. It's running on running a server at localhost at port 9999. So the instruction said, open an HTML web browser on remote host and post this URL in. Okay, sure, let's do that. Copy, link address. I'm going to fire up a web browser. Cool. Now I'm going to paste that link in and watch what happens. Boom. Welcome to the Autopsy Forensics browser. This is your suite to manage your case. This is your suite to start to manage your case. And we have a case that involves one drive. So I want to open up a brand new case. Case number. Let's use case number is forensics. Let's do comp 116 dash 2020 1203, which is today's date. And the description is live on Twitch, analyzing evidence analyzing disk. Investigator's name, optional with space of the investigator. I'm going to put me on there. Okay, cool. I'm going to create a brand new case called Comp116-2020-1203, live on Twitch, analyzing disk, one investigator, me. Okay, creating case, yada yada yada. The case directory has been created. Configuration file has been created. Now we must create a host for the case. Please select your name. Yeah, okay, sure. Add host. Add host. The name of the computer being investigated. It can be going to contain the evidence and numbers. What can I put for a host name? Let's say evidence 2020. You can name whatever you want. Description: bikini bottom Twitter. Put the time zone, which is optional. I'll just follow the instruction. Time adjustment, whatever. Hash database. Path of alert had an optional hash database of known bad files. Like, for example, if you're doing like a pornography case, you may want to upload a hash of all like known bad images. Also, you can also upload a hash database of known good files as well too. We're not going to do that. I'm just going to say add host. Okay. Evidence 2020-12 the case. Host configured. Now we must import an image file for this host. This is important. Let's go to add image. Let's go to add image file. So the location, let's do this. They said enter the full path to the image file. If the image is split either raw or encase is like the bona fide, like professional grade, costs a lot of money for computer forensics. It's like the de facto standard used in law enforcement and in government. Then enter the star for the extension. Okay. So I'm going to go home, defcon evidence.dmg. Okay, this is a disk. I want to open up a brand new tab here. I want to show exit to do an ls. home/defcon/evidence.dmg. Now I want to actually have represented an option, the import method. To analyze the image file, it must be located in the evidence locker, which is in var. I think the evidence locker is something said here. Evidence locker is /var/live/autopsy. Cool. To analyze the image file, it must be located in the evidence locker. It can be imported from the current location using a symbolic link by copying or moving it. Notice that if a system failure occurs during a move, then the image could be corrupted. I'm going to do a move because I want to move that evidence.dmg file from my home directory into the evidence locker. I'm going to hit next. Okay. Did it get moved? Let's go back to this tab. Not yet. Okay. Do we want to data integrity? An MD5 hash can be used to verify the integrity of the image. Split the file, yeah. Yeah, let's calculate it. Why not? Let's calculate it. Always nice to calculate the hash. Always very, very, very critical to calculate the hash value for the image to maintain integrity. Analyze the image that shows the following partition, mount point. Okay, FAT16. Sure, looks good. Let's hit add. Current MD5, testing, moving partition. Okay, all right, looks good. Okay, cool, looks good. Did it get moved? Yep, looked like it got moved out. So I don't need this anymore. All right, I'm going to hit OK. Looks good. And here we are. We are working on case Comp116-2020-1203 on the evidence-2020-1203. So here's my case gallery. And this is where you do all your analytical work, all your analysis work. We have two kind of disc here. We have a disc and we have this mount point of a C FAT16 disc. Let's see the details of these. Let's extract strings. Got anything good? Nothing nice. All right, but what about this one? This may get interesting. Ooh. Evidence.dmg, raw, FAT16 type. We can extract strings of the entire volume. Let's not get to that yet. Let's analyze this disk if we can get anything. I don't think there's anything here on disk. This is not the special thing. You can do a keyword search, file analysis. Oh, a lot of file analysis, keyword search, file type, image details, metadata, data unit. So these are, well, I can't do file analysis. I can't do file type. I can't do data unit. Well, it's not that special. Let's close. What about this one? Let's try to analyze the mount point C, FAT16. This looks like our main disk. This looks like the mount point that contains everything that we saw earlier today. Ready? Let's hit analyze. Now it looks a little different. We can do file analysis, we can do keyword search, we can do file type, we can do image detail, we can do metadata, we can do data unit. Let's see what we can uncover. The obvious first place is let's do a file analysis of what is on this disk. Ooh, interesting. I see a lot of red. I see metadata. Ooh. Wow, interesting. Wait a minute. Take a look at the table. You have del, which probably means deleted, whether it's a directory or I don't know what in is, I forget. The name of the file, the date written, the date accessed, created, size, UID, GID, meta. Notice, if you probably can gather from this table, red means the file got deleted. Remember, we saved two text files, not one. We saved two text files. Remember this one, the stack one? Let's see what happens when we click on it. The contents of C stack. Yeah, smashing the stack for text and profit. This is what I saved this. We can even say the JPEG file, and you can see all the binary data of the JPEG .wp file. Look at all the deleted files in red. That's there too. Even all the deleted files we can see. How does calculating the MD5 hash of the image relate to its integrity? Well, here's the deal. When you that's the whole point of calculating the hash of anything. Like when you calculate the hash of a file or a disk image, well, it'll give you back a hash value. But if anything changes later on or before, or if the disk got corrupted, you're going to get a different hash value, which is inconsistent. The hash values, like let's say for example you have 10 investigators. If 10 investigators are using the same evidence.dmg file, if each and every one of those 10 investigators are using that evidence.dmg file, the MD5 checksum should always be the same. If one person is working with an evidence.dmg file that has a different hash or checksum in the end, you know that something got tampered with. I hope that answers your question. Now, it's a good question and a friendly reminder of why calculating the hash value is so important. You know, the hash value should be consistent across the board if everyone is using the same disk image or even like individual files itself. If one person is using a evidence.dmg file and evidence.dmg file and is different than all the other ones, then something got tampered with. Let's go, wait a minute. We got the frac logo. Didn't we actually have another txt file here of some sort? Can we find it here? What's this? Ooh, yeah. Oh, that's there. All the deleted files are there. Yep. Yeah, even the files. Look at it. We can even see all the files that got deleted. Way crazy. Remember, is it still on my desktop? Yeah. Remember, if I mount the evidence disk here, and the original evidence disk is only 2 items here, 2 items as you can see, not 11 because the other stuff got deleted. This one got uploaded to Kali. Yeah, it's only showing up, these are not deleted files, these blue ones. So we can see all the deleted files, all the hidden files. What about metadata? What's that like? Oh, okay, nothing so far. Image details, here we go. You're going to have everything about the disk, file type. Wow. If I got a file type, and I go sort by file type, it says it found 12 images, 3 texts, 29 unknown files. Found everything. Crazy. Keyword search. Can we do like Twitter? No. You can even do, let's say for example, you know, predefined searches have date, social security number 1, social security number 2, credit card numbers, IP address. No. Let's go for profit. Okay. Well, let's do an extract strings. See what happens. Let's extract all the strings. Let's see what happens. Oh. Keyword search. Go stack. Boom. Let's do a brand new search for the word the. I mean, this is pretty dumb, but 700 pounds, 738. Yeah. Brand new search or search for code. Oh, let's go look for shellcode. 44, if you see 44 occurrences of shellcode, We can also look for GDB. 18 instances of GDB. And you're going to do real keyword search of text. Way cool. Wow. Found a lot. So now I want to, well, you can even close the host. Oh, image what's image? Speaking of the crusty computer, what is this image integrity thing? Oh, there we go. $2cc A81E, all the files. Well, I still got my evidence.dmg file on my desktop. So I can do an MD5. Like, let's make sure that nothing got tampered with when I uploaded evidence.dmg to Kali. So I'm on my Mac now. I'm going to do an MD5 sum of evidence.dmg 4E4. Uh-oh. Uh-oh. Weird. That's weird. The original MD5 with 2cc8. What? Really? Weird. We got a problem here. Hold on. Let me go to brand new tab. CD comp 116. CD evidence. CD images. Okay. $2cc8B. Wow, that's weird. Huh. Oh, that's not good. I don't know why it's doing that. I don't know why we have a mismatch here. So I'm a little concerned now, is that the MD5 sum definitely matches up. 5050200864. Huh. Okay. That's really messed up. Why would it actually give me a different hash value than it was before? Maybe because I made a small change in when I opened up the evidence.dmg, it may have caused that problem. So this actually goes to crusty computer. Something got tampered with, probably on this end, on my Mac end, when I opened up the disk. So that's why checking the checksum is important, because I'm running into a case right now that the MD5 checksum, let me go back to my desktop again, same file size, same everything, but the checksum is different. I mean, they should match up. Interesting. That's not good. This is not the same. The 2cc does not match the 4e4 hash. Well, if that's the case, what I will do, I'm going to go copy this. I want to try something for a second. What if I download, I'm just doing an RM of evidence.dmg. Let's remove this one. But if I do scp Kali, oh, didn't want that. So I'm going to do scp Kali. I thought I could, oh, var live autopsy comp 116 star evidence star images star.dmg. I'm going to save it to my desktop. Okay, here we go. So I am now downloading the evidence file that I uploaded to Kali. Let me do an MD5 of evidence.dmg. This will show there's something really, really wrong with, okay, so now the checksum values matches up. 2cc, 8b, 29, A5. Okay, so now, thanks Krusty Computer. This is why hash checksum values are very important. They should match up. Evidence.dmg, 2cc, evidence.dmg, 2cc, 81e. So it matches up. But wait a minute. Is it, do we get the same result if we double click on it? Let's take a look. So if you go open up the evidence drive, yep, 2 files, 2 items. I want to eject this disk now. But wait a minute. Now that I've ejected it, what happened if I do an MD5 again? Don't tell me, is it true that the checksum of the disk image will change after every transaction, like when you open and close it? I don't know. Huh? You don't say. It does. It changed. So when I mounted the disk, dismounted the disk, something got changed, and okay, therefore the checksum changed. Wow. Who knew? I never knew that. I learn something new every day. Really? Even if I mount the disk, unmount the disk, and I calculate checksum, it's going to be, yeah, it is different. Yeah, very interesting. Yeah. So even that operation, when you dismount the disk, wow. This is the first time I've ever done that. When you dismount the disk, it does make a change of some sort, and the checksum changes. Very interesting. I mean, it's still a 50 megabyte disk. Maybe the timestamp got changed onto something here. Wow. Very interesting in core. Yeah. And this is a flat disk. All right. So here we are. We just learned Autopsy and Sleuthkit. Okay. So here I am in the evidence locker. Evidence.dmg. One of the things that I now want to use is, let's move out of, did we close out of this yet? Okay, it looks like it's still running of some sort. Let's do Control C. Let's get out of Autopsy and Sleuthkit now. No, we don't need that. But now, let's do one of my favorite tools. What if you have a DMG file, a disk image, and you just want to just extract all the pictures or all the text files? Again, the problem is, let's say you're given a disk image like evidence.dmg. What if you just want to extract all the JPEG files? What if you want to extract just TXT files? Can you do that? The answer is yes. That's called file carving. And I want to introduce to you something that I presented on way back in the days. I want to go take back the time machine and go back to 2009. In 2009, I gave a presentation to the High Tech Crime Investigators Association, the HTCIA. I used to be a member. It's kind of sad to think about it, because if this was a normal year, we would be having a Christmas party the group would be having a Christmas party right now. I only have fond memories of working with them. But I gave a presentation back on September the 22nd, 2009 to the HTCIA on investigation and incident response using Backtrack. Backtrack was what is now Kali Linux. And Backtrack, of course, again, it used to be what is Kali now is called what's called Backtrack in the past. And a lot of the information on this presentation I did like 11 years ago still holds true up to this day. But one of my favorite tools, and it is part of Kali, is called Foremost. Foremost was developed by the DC3, which is the Digital Cyber Forensics. No. Is it? Oh, wait a minute. What is the DC3? I need to get this one right. It's the Department of Defense Cybercrime Center. Jim Christie my friend Jim Christie used to run that place. Want to give out the shout out to Jim Christie. And so what Foremost is file carving and recovering. That means if you just want to rip out the JPEG, if you just want to rip out like TXT files. So I even presented an example, a crystal clear example in here. If you want to search for JPEGs only, skipping the first 100 blocks on the disk, is Foremost minus S 100 minus T for the type, JPEG, and minus I for the name of the image. I'm going to leave this open. I'll go back to Kali. Foremost. Recover files using headers, footers, and data structures. This also includes deleted files as well, too, of course. Recover files from a disk image based on file type and specified by user using the -T switch. -T, it can recover JPEG, GIF, PNG, BMP, AVI, EXE, MPEG, WAV, ZIP, MP4, CPP file, all those things. So now, we are given an evidence.dmg file here. Can we use Foremost and just extract all the JPEG files from this? Let's take a look. So we want Foremost minus S 100 minus T. Let's extract all the JPEG files. Minus I for the disk image. Evidence.dmg. See what happens. So hopefully that this command and tool Foremost will rip out all the JPEG files, even the deleted JPEG files, off of evidence.dmg. Let's see what happens. Ah, crap. Permission denied. Unable to open directory. Well, if that's the case, well, there's always a trick with any permission denied things. I just put a sudo in front of it, a command, and let's see what happens. Boom. Oh, interesting. An output folder. Oh. And you know what? Oh, because I had to create this folder and it's by root. So you know what? I'm going to sudo change owner -R defcon output. Take a look. Take a look at the audit log. Foremost recovered 5 JPEG files off of the disk. Let's open a file browser. Okay, we ready? Let's take a look at what images got recovered. Mm, 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 mm. As you can see, a lot of these pictures were deleted. Mm. Brought back all the JPEG files. So this shows what I've just done today, just shows you what happened when you delete a file using straight RM or just empty trash. It really doesn't delete the file. You can always recover it. Let's do this again, but this time I want to recover all the TXT files from offofevidence.dmg. See what happens. What? Did it work? Yeah, you know what? Let's start from scratch. Minus T. Wait, I said evidence.txt. Let's do PNGs. Hmm. Oh, change owner. One PNG file extracted. Wait a minute. What was the picture in this thing? Yeah, that's not the that's one of the pictures that got deleted. So we can even recover the PNG because what's on the disk still is this. So we even recovered the PNG file, which is nice. Yeah. Cool. So one last thing. So what happens, one thing we didn't talk about today is, so we've gone over Salute Kit and Autopsy. We've done file carving with Foremost. And heck, we recovered JPEG files, PNG files that were deleted off disk. So what happened if you have to use, if you're trying to do bigger disk? What happened if you're trying to recover stuff off of a USB drive? So if you're trying to recover files off of, let's say, an 8 to 16 gigabyte USB drive, you will need to make a direct bit-by-bit copy of that entire drive first. And the quintessential tool to use to make a bit-by-bit copy of any disk is convert and copy, more famously DD. DD, convert and copy a file. Okay, so convert and copy a file is using DD. This is the best way. This is like the quintessential way to make a bit-by-bit copy of a file. So usually to do a bit-by-bit copy of a file, you do something like sudo. I'm not going to do it. I'm not going to run this. In file equals dev sdb of equals evidence.dd, and then bs equals like 1 meg, something like that. Okay. So you know, if you're going to be trying to recover files off of a hard drive or off of a USB drive, you want to use DD, convert and copy. Sudo DD in file input file equals output file, which is OF equals whatever you want. BS equals 1 meg, or some other number. There's also some other copy tools that you can use. Like for my old presentation, you can use DD underscore rescue. Used to rescue a damaged disk, unlike DD. If DD underscore rescue tries to read and fails, it'll go on to the next sector. Oh, cool. Is DD rescue on here? Go to forensics. Digital forensic DD. No, I don't know. Oh yeah, wow, look at that. It's also DD underscore rescue, data recovery and protection tool. DD underscore rescue is a tool that copies from a data source for one other type of file. DD underscore rescue does not copy with large blocks to increase performance. Wow. DD underscore rescue falls back to similar to reading blocks to allow the max to recover the maximum amount of data. Huh. Okay. Part of Cali, and of course the other one is DCFLDD. This was created by the Department of Defense Cybercrime Center, DC3. DD does have some shortcomings. Yeah, this is pretty cool. And just thanks for Crusty Computer. Calculate the MD5 checksum while the hard disk data is being copied. Has a status bar, can also be used to wipe disk. Okay. To copy an entire NTFS drive, which SHA-1 of the entire drive, that's the command. Is DCFLDD on Kali? I think it is. Yeah, DCFLDD is there. Yeah, there you go. Enhanced version of DD for forensics and security. Copy a file, converting it, and formatting to the event. Yeah. Well, there it is. Wow, look at that. The DCFLDD was initially developed by the Department of Defense Cyber Computer Forensics Lab, DCFL. This tool is based on a DD program with the following additional features. Hashing. Wow, look at that. After all these years, some information stayed the same consistently, which is nice to see. Wow. And so there you have it. I mean, it takes probably for a 16 gigabyte disk. Off the top of my head, it could take like an hour to do a bit-by-bit copy of a 16 gigabyte USB disk. And is this how you would recopy an iPhone hard drive? You better believe it. This is it. Mm-hmm. Oh yes. To answer your question, is this how you would copy an iPhone hard drive if you have access to the hard drive? Yep, you better believe it. Let's see how this really works. I can just log out of here now. I want to look into this. Hold on. Wait, hold on. Don't need this anymore. Yeah. So let's talk about phones now. Well, by the way, so let me go to answer EDEO 5000's question. This is definitely the way to copy an Android drive for sure. Android is much easier to work with. Okay. Yeah, huh? don't believe it. Yeah, exactly every day. An Android create a DD image of Android for forensics. Yeah, wow. But it doesn't answer your question about iPhone. Android forensics analysis with Autopsy? Wow, I never knew that. Latest version of, oh wow, here's an interesting. A latest version of, you can do like text. Wow, pretty cool. This is a newer version of Autopsy. Case info. Wow, you can even have plugins for Android phone. Cool, cool, cool. DD of iPhone hard drive. Let's say iPhone forensics. I wish there was a cop or some forensic law enforcement experts actually to there is an iPhone forensic. Okay. Huh? Look at this. Let's go here. iPhone, iOS, and iCloud forensics. Nothing come closer to even an Android land. Yada yada. No, thank you. iOS. Yada yada yada. Huh? Physical acquisition, here it is. Physical acquisition is the only method that could create a copy. It is similar to DD for, for traditional hard drives. It's in fact a lot of data, not including iPhone backup. Huh. But yeah, I mean, the general idea is the same. I don't know if there is a DD equivalent for iPhone land, but I think it's got to be a commercial software that does that. Yep, iOS 4 was the good times. Yep, the traditional way of making a copy of a disk, DD. Oh, wow. iOS forensics things. Technical draft is really old. Things have changed, of course. I don't think this holds. Backups. Wow. Yeah, these were the good old days. But yeah, for iPhone copy of iPhone hard drive, something similar to DD. Android, yep, use DD. And that's all I got for today. Cool. Thanks for tuning in, everyone.